All right, so let's all turn to page 34. So assuming that everybody got the standard form now, okay? So we got the y equal to a, right? And then x minus p squared plus q, right? It's the standard form correctly. Now we're gonna talk about the transformation. Transformation means you are changing the shape, changing the look of the graph, okay? So transformation of a function includes three things. One is the reflection, right? Stretch, and then translation. So all together is called the transformation. Okay, so each of them do different things. So I put them in order like this because you have R, right? Look at the bolded letter, right? RST, okay? So when you are doing transformation, you always go in that order, alphabetical order. So each one of them can give the original graph a different look, okay? Original graph. Original graph is referring to this one right here, y equal x squared, okay? Because for this one, if we compare, right, if we try to tell the APQ, what do you think the APQ is? Let's write it on the side, okay? APQ. Let's put it this way. Okay, so what's the value of A? Aaron?
1.
Yeah, 1, right? There's no number in front, right? No number in front means an invisible one, okay? And let's find the Q, right? Because usually the A and Q are the easy ones. What's the value for Q then, Brendan?
0.
Yeah, very good, okay? Q is the number after the square, and after the square, there's nothing. So that means it has to be 0, okay? And what about P then, Colin? What's the value for P?
0.
Yeah, also 0, right? So think about if I sub these three numbers, 1, 0, 0 into the form, right? Y equal to 1, x minus 0, squared plus 0, right? Because 0 is gone, right? Minus 0, it doesn't do anything, right? 1, make it invisible. So it becomes y equal x squared, okay? So even though it's written like that, it still has the APQ. So it's the simplest one. That's why it's called the original graph, okay? It doesn't have any extra things. So let's look at what the basic, okay, or the original one look like. So we'll start with the table of value, okay? So for x value, we will just put -2, -1, 0, 1, 2. So that way we have some negative values and some positive values. And then just like when you are finding the drawing the linear, right? You will plug in the x to find the y, okay? So to get the y values, right? Y equals to x squared, right? So you plug in the x into the brackets. So for the first one, right? For this one, will be y equal to -2, right? Squared. So that will give you a 4. All right, so please complete the table and raise your hand. Anyone has trouble getting the table? Okay, if you finish the table, please raise your hand. Okay, Eric, any questions?
Not really.
Finish the table? Have you finished the table, Eric? Yeah, okay. So let's have Yosher, can you tell us your y values now?
41014.
Yeah, very good. Okay, so everybody please plot them on the graph, on the grid, and then we'll draw the picture. Okay, so -2, 4 will be up here. -1, 1, 0, 0, 1, 1, 2, 4. Okay, so as you can see, they don't line up in a straight line, right? It makes a curve. So when you connect, right, don't use the ruler, right? Just freehand. Okay, so if you like, you can plot more points, right? Then you get more accurate graph. And the next one will be, the other side will be here. Okay, so the point that is at the lowest place, right? This one has the lowest place. That point is called the vertex. Okay, so we can write that on the top here. Vertex is 0, 0. Okay, so this is our basic function. It has no extra stuff attached to it, right? The simplest form. Okay, if you finish the graph, can you raise your hand? Okay, Eric, have you finished the graph yet? Yeah, okay. All right, let's move on. Okay, so now we are starting to add stuff in, okay, change things. Right, the first one is called the type 1 is called reflection, right? So reflection is flipping, right? So let's take a look how will this one change the graph. This time we have a different APQ, right? APQ. So what's the APQ for this graph now? Sarah?
A is -1.
Yeah, A is -1. How about PQ?
They're both 0.
Yeah, both 0. Okay, so P and Q stay the same, but A is now -1. You can highlight this, right? Used to be 1, now it's -1. Okay, so let's take a look how would that change the graph. We'll use the same X values. Okay, and then please do the same thing. Plug into the function that we have, okay, the quadratic function. So this time, instead of just bracket square, we have -x squared, right? So you plug each number in, square it, and then times negative. So negative does not go away, okay? So when you finish the table, please raise your hand again. Right, and Eric, can you tell us your Y values?
-4, -1, 0, -1, and -4.
0, -1, -4. Okay. Okay, good. So you can continue to make the graph. -2, -4. -1, -1. 0, 0. 1, -1. Right, so everything times it by negative, right? Okay, so the arrows goes differently. So what happened here is we said there's a reflection, but how would you describe it, right? There's a saying here, right? Say means you describe the transformation. So how would you describe the reflection? It's reflected over where then? Nathan, what do you think? If you want to describe what happened.
It's reflected over the center line or the X.
Yeah, okay, the x-axis then, right? So you can call this line, right? The one I'm highlighting with the blue line, that's the x-axis. So it's like you look into the lake, right? The mirror. So the bottom part is the reflection of your image, right? If you're standing on the top, right beside the river, then you'll see your reflection of yourself in the river, right? In not the river, the lake, okay? So this is the reflection over x-axis, okay? So you can write that down. So this is the first time we talk about transformation. In grade 12, we have a whole chapter about transformation. So there will be other kinds of reflection, okay? You could also have graph reflecting over y-axis and also reflecting other axes as well, okay? Not just x and y axis. Okay, any questions? Okay, if you have no trouble, can you raise your hand and then we can move on to the next type. All right, perfect. Okay, so let's look at number 2. So far, right, also we added in, okay, this part we forgot, right? Vertex is still the same place, right? This is the vertex, right? So this time the vertex is actually the highest point now, right? Not the lowest. So the vertex is at 0, 0 again, okay? So look at, so this part, right? If A is positive, right? Before we move on, we'll conclude this part. When A is positive, it will be opened up, okay? We can write that over here as well, opens up, right? And then if A is negative, it opens down. Okay, open means like the two lines, right? It's like a mouth, right? Or it goes wider and wider, right? Gets bigger and bigger, so it opens up to the higher direction, and then the other one is opening downwards. Okay, should be pretty straightforward there. Okay, let's look at the second part now. We'll also look at the APQ before we start. APQ. So what is the value of APQ this time? Colin? What's the value of APQ for this question?
200.
200, very good. Okay, it'll be 200, right? A is always the number in front of the x squared. Okay, so we'll use the same x values to find the graph. So this time the y, you need to find it by multiplying by 2, right? So y will equal to 2 times something, right, square. So follow the order of operation, right? You have to square first and then times 2, okay? Do not times 2 and then square. Order of operation, you need to do exponent, right, before everything else. So please complete the table and raise your hand. This time I'll let you complete the graph too, okay? So finish the graph and the table, then you can raise your hand. Okay, let's check the table of values first. Okay, Aaron, can you tell us your y values?
82028.
Okay, all right. And then let me plot that. Colin, do you have any questions? Did you finish the graph yet?
I forgot to raise my hand.
Okay, so -2, 8, -1, 2, 0, 0, 1, 2, 2, 8. Okay, so if you want to describe what happened, right, in your own words, how would you describe? Okay, describing means you compare with the original, right? The basic one, the one on the top. You want to describe what happens. How would you say it? Yosher, what do you think?
Everything was like squared by 2
Square by 2.
or like multiplied by 2.
Okay, and how about the shape? If you want to describe the shape, what happened?
It's like skinnier and like longer.
Yeah, very good. Okay, so it gets skinnier and longer. And then if you compare the table, right? If you want to describe using numbers, then you look at the table, right? The x is the same. So if you look at the y, right? I'm highlighting all the y. You can see that all the y value is times it by 2, just like Yoshir said, okay? And the y is going vertically, right? So also she said it's taller, okay? So we can say is going vertically. Vertical means up and down, okay? Vertically gets bigger, so we call that expand, okay? Bigger means expand. So it's pulling, it's like, think about a rubber band. Right? I want to pull this rubber band up and down, right? So I'll pull this part, go down, pull this part, right? Pull it up, so it will look like the shape down here. Right? Of course, the vertex is still the same place, right? But it gets skinnier. So because the y value got double, right? Times it by 2. So the way we'll say is vertically expand by, you can say by factor of 2, or you can just say by 2, okay? So vertical means it's y, the y got changed. Expand means it's getting bigger, okay? And then the 2 is the number that you need to multiply by, all right? And then the vertex is still doesn't change, right? So this one is vertex, it's still at 0, 0. Okay, so it's all good. All right, so let's take a look at next one now, right? So you can see so far, the A not only controls the opening, right? Like this one, A is positive, right? So it opens up, right? Even before we graph, we know it's gonna be opened up. Not only it controls opening, but it also tells you how big the Y value will be, right? So if A is 2, it gets expanded by 2, okay? So the next one, apparently the A is half this time. So any guess on what will happen to the graph? Right? How would you describe what happens? Any volunteer?
Expand horizontally
Say that again.
by one, like expand horizontally by
Ex-
1/2.
Okay, expand. Let me write that down here. Okay, expand horizontally by 1/2. Okay, anyone else? Any other guess?
I just say it like shrinks by
Shrinks?
like half
Which,
of the first graph.
say that one more time. I can't hear you.
It shrinks by like half.
Shrink by half. Which direction? Is that vertically or horizontally?
Vertically.
Vertically shrink. Okay, vertically shrink by half. Yeah, also the word, okay? Here I use expand, right? So expand is the same as the word stretching. Okay, but some textbook use the expand, some textbook use the stretch, okay? Most textbook they use expand, okay? But then the reason why I choose stretch and shrink is because I want to put in order, RST, okay, just to make it in line, right? So, but in your head, right, just remember that we most of the time use the word expand. So instead of shrink, it will be compress, okay? So you can put it underneath. Stretching is expand, okay? Shrink is the compress. Okay, so let's take a look, okay? We'll see which one of these two, okay, is the answer. Any other guess on what will happen to the graph? Okay, so let's try out the table, okay? Then we'll see the picture tells 1,000 words, right? So please fill out the table and then complete the graph. Once you've done both, please raise your hand. Okay, so the y value, you need to times it by half after you square, okay? Remember to raise your hand if you finish the graph. Okay, so can I have Brandon's? What's your value for y?
2, 1 over 2, 0, 1 over 2, and 2 again.
Okay, thank you. Okay, so let me quickly plot that. -2 goes up to 2. -1 goes to half, right? And then 0, 0. And then 1 and half, and 2 and 2. Okay, if I want to try 3, right? Because the points are really low here. So if I add one more point, right, just to see what will happen. So 3 squared is 9. 9 cut in half will be 4.5. Okay, so let me plot one more, right? So our graph is more accurate. 3 will be 4.5. The other side is the same, right? Symmetrical. Okay, so now the graph looks like this. Okay, so this one, if you want to describe what happened, right? Describe the transformation, then you will compare the y values again. So look at all the yellow highlighted, right? Compare the basic with the new one, right? Used to be 4 on the top left corner, right? Now become 2, right? Cut in half. 1 become half. 0 stay the same, right? So everything is cut in half. Or you can think about this one, right? The basic one, instead of pulling vertically, right? Pulling up, pulling down, we are going to, okay, we'll be pushing it downwards, right? We push this line down, right? Actually the 0, 0 doesn't do anything, right? So all the point goes lower, right? We're squishing it to the ground. Kind of, you can think of that way. We're squishing it to the ground, so it actually gets shorter, okay? So with the same x value is only half as tall as before, okay? So it should be vertically, right, instead of horizontally, because everything is working on the y value. The x doesn't change, okay? So it will say vertically, right? And then because it gets shorter, so you can say shrink, right? Or you can say compress. I'm gonna use the word compress. Vertically compressed by 1/2. Okay, so when you see that, right, the half, right, the 2 is the A, right? So half is also the A. Okay, whatever the A is the number that you compressed. But be careful here. Okay, so good try. Okay, on saying your answers. So remember, A can control two things, right? It can also control the open up and down, right? So if I have an extra negative, right? If there's a negative, I'm using a green, okay? If A is -1/2, then your description, you still have to say vertically compressed by 1/2, okay? Because the negative controls open up and down. So the only difference it will make is to make this graph open down, okay? It's still the same shape. It's still compressed by 1/2, but the graph will be going downwards. Okay, so you can use a different color to show that. Okay, this one is 4.5. Okay, so if it's the green one, right, having an extra negative sign. Okay, actually let's not mess up the original question, right? So let's just write it beside the graph. Okay, for the green one, it will be y equals -1/2 x squared. Okay, so that way you compare. Okay, and for the red one, it will be y equal 1/2 x squared. But both of them, you still say vertically compressed by 1/2. Okay, do not say vertically compressed by -1/2, right? So when you use the expand or compress, the number is always positive. All right. Do we have any question? If you understand this, can you raise your hand again? Nathan, any questions? Okay, you're good. All right, so let's make a conclusion, okay, of everything we've done so far and into 2 sentences, okay? So first one is the A, right? So A, positive, okay, or rather underneath, you can write conclusion, okay? First conclusion is if A is positive, opens up, A negative, opens down. Oops, opens down. Okay, the graph that we've been drawing, those are called parabola. Okay, so you can write parabola. Okay, or you can call them quadratic function. Okay, it's a longer name, or you just call it parabola. And then second conclusion is talking about whether it expand or compress, right? So A, okay, so, and because, like I said over here, you only make it positive, right? Even if it's negative, right? If you are given this question, the green one, when you talk about expand or compress, then you ignore the negative sign. You just make it positive. We call that absolute value, okay? So you put 2 bars around the A, okay? I need to check, okay? Have you heard of absolute value? Can you raise your hand if you know what absolute value means? Okay, so rest of you don't know what it means? Can you raise your hand if you know what's the 2 bar represent? Okay, so only 2 people, right? So Eric, can you tell us what does absolute value do?
So like the value inside the 2 bars will always be positive.
Yes, very good. Okay, thank you. So for example, a is -½ right? So -½ absolute value, right? Later on in grade 12, you'll have a chapter on this too, okay? So 2 bars, when you put 2 bars on the negative number, whatever comes out will be positive, okay? So basically, what it's doing is telling you to ignore the negative sign, okay? For now, just remember that. Just a symbol, okay? So absolute value around the number, it makes it positive, which is the same as what I want you to do, right? When you get a negative value for A, you ignore the negative sign, okay? Is that clear? Okay, can you raise your hand if you understand this? Okay, yeah,
Can I copy the thing down?
yeah,
Like
yeah,
the notes at the bottom.
yeah, okay. Yeah, so absolute value of A, right? Once you make it positive, if that number is greater than 1, okay? So for example, like absolute value of 2 is 2, right? After you ignore the negative sign, if that number is greater than 1, it will expand. The parabola will expand. Okay? So if A is 5, then it will expand, right? If A is 3/2, it still expands, right? Because it's bigger than 1. Because any number that times it by something that's bigger than 1, it will become bigger, okay? But you got to ignore the negative sign. So that's why the absolute value there. All right. And then same thing, the opposite, right? If after you ignore the negative sign, if the number is less than 1, so like the -½ right? You get half, and half is smaller than 1. Okay. Or like if the A is negative 0.5, 0.7, right? Ignore the negative, it's 0.7, smaller than 1. Then this will make the parabola compress. Okay, so that's the 2 rules on this page. Okay, so can you write these down? Okay, after you write this down, I would like you guys to turn on your mic. Okay, we're gonna repeat these 2 rules together because these are very important. Okay, so yeah, once you finish copying it, you can turn on your mic.
Jason,
Yes, Eric?
will it be going over like the other ones, like x cubed or like 1/x?
No, we won't. It's not in the grade 11.
Oh,
Yeah.
okay.
Yeah, that the x cube is in the grade 12. Yeah, and also the 1/x. 1/x is later on. Yeah, we have another chapter on the 1/x graph. Okay, it's not in the parabola. Okay, please open up your mic if you finish copying. Brandon, Eric, almost done.
Yeah, I'm done.
Okay, Eric, turn on your mic, please. Okay, so let's repeat this together. Okay, well, I'll say it first and you guys can say it all together. Okay, so A positive, everyone.
A
A
positive.
Positive.
Very good. Okay, one more time. A positive
A
A
positive.
positive.
opens up.
opens up.
Opens up.
I only
Opens up.
hear 3 people saying. You see your mic. Okay, moving. Sarah, you sure? You guys speak up, please. Okay. Okay, one more time. A positive opened up.
A
A
positive.
positive opens up.
That's better. Okay. And A negative opens down. Everyone.
A
A negative opens down.
Opens down.
Okay, very good. Next one. Absolute value of A greater than 1. Everyone.
absolute.
Absolute value
value
A greater
Value
than
greater
1.
than 1.
Nathan, yeah, are you saying it? Okay,
Yeah.
one. Absolute value of A greater than 1.
Absolute value of A greater than
Absolute value
A
greater than 1.
Very good. Expand.
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 Okay, next one.
Expand.
Absolute value of A less than 1 compress.
Absolute value
Value.
less than 1.
Less than 1
Less than
compress.
1 compress.
Okay, yeah, so just remember the more you repeat, the stronger impression it leaves in your head, okay? Just like trying to memorize your phone numbers, right? You repeat many times when you don't have a paper to write it down, right? Okay, so let's have a break, okay? Right now it's 6 after 11. You'll come back, I'll see you guys at 11:20, okay? And if you have a question, you can stay after.